Starting with the fifth lecture of chapter hydrogen, we are discussing organic ion exchange method to purify hard water. So this is our lecture number 5. Discuss organic ion exchange method for purification of hard water. This is also called as resin method. Because in this method we use the resins which are having active H positive ion at their terminal and or OH negative ion at another terminus. So resins, these are the hydrocarbons, chains having active H positive and OH negative ions at the terminus. They are packed in the two chambers. First chamber contains H positive resin. From here we are adding hard water containing calcium, magnesium ions, chloride ions. This chamber is sprayed with dilute NaOH. Here we are keeping pebbles or stones, glass stones at the bottom, and then we are having H positive resin. Now hard water comes here, it will be losing calcium and magnesium ion in this chamber, and then this water is taken to other chamber which is packed with OH resin. Here chlorides, sulfates and H positive, they come here, they are removed. So now this is called as cation exchanger. This is called as anion exchanger. So reaction in cation exchanger, H positive resin takes off magnesium ions, forming Mg resin twice plus 2H positive. Similarly, it can take up calcium ions. Now reactions in the anion exchanger resin, we have OH negative resin. It takes up chloride ion of the hard water plus OH ions are liberated here. Similarly, OH negative resin, it takes up sulfate. These OH ion combined with H positive ion coming from that chamber and giving you soft water. Now for regeneration of resin, from here we add dilute HCl. For how to regeneration of cation exchanger. Cation exchanger resin has changed into Mg twice resin. It is now sprayed with dilute HCl. MgCl2 goes off, H positive goes with resin. So here we will be spraying dilute HCl. In this chamber we will be spraying dilute NaOH. So now regeneration of the anion exchanger resin, sulfate reacts with 2 NaOH here, added from here, it will give you Na2SO4 precipitate plus OH resin. So resins are generated in the end and can be used again for the purification of water. So this is the way how we purify hard water, how we convert hard water into the soft water by using organic ion exchange method or resin method. Then we have the next question, why D2O is poisonous. Now D2O is poisonous, it is due to low reactivity of D2O and D positive ions toward the biochemically active enzymes. They are not so active towards those enzymes, and moreover the reactions, biochemical reactions, they are slower in the presence of heavy water because the rate of action of heavy water is different due to its different mass. It is having more mass, so its reactivity will be less in the body. That's why it is thought to be less useful for us, or it is thought to be poisonous to us. Now, what are the uses of D2O? It is used in the nuclear reactors to slow down the fast moving neutrons where the electricity is to be produced. So it is used in to study the mechanism of some of the reactions, and it is used to prepare deuterium D2 gas by electrolysis of this water. Now we come to another important topic of this unit, that is hydrogen peroxide, preparation of hydrogen peroxide and its properties. Our next question is, give preparations and properties of hydrogen peroxide. So answer, first of all we take the preparations of H2O2. Number one is Marx process. Sodium peroxide, when treated with concentrated H2so4, it will give you H2O2 plus Na2SO4. So Marx process involves the conversion of sodium peroxide into H2O2 plus water. Second is from barium peroxide. Barium peroxide is a octahydrate oxide. It reacts with H2so4 concentrated to give us barium sulfate plus H2O2 plus 8 water. It can also combine with 3BaO2, 2H3PO4, will give you Ba3PO4 twice barium phosphate plus 24 water molecules and plus 27 water molecules in this case. 10 water molecules will come from here. So this is the reaction. Third is by electrolysis of H2so4. H2so4 first of all ionizes to give you H positive and HSO4 negative ion. Reaction at cathode, 2H positive take up electrons and change into H2 gas. At anode, 2HSO4 negative, they will lose electron too and will come here in the form of H2H2O8 plus 2 electrons are released. H2H2O8 combines with H2O to give you H2O2 plus 2H2SO4. So in this manner we can prepare H2O2 from sulfuric acid. Then we have by the electrolysis of ammonium bisulfate. Ammonium hydrogen sulfate. It first ionizes to give you H positive plus NH4SO4 negative. Then at cathode we know H positive ion combined to produce H2 gas. At anode, it is anion will go to anode. We get 2 NH4 SO4. Then it will combine to give you NH4 twice H2O8 plus 2 electron. This will now combine with NH4 twice H2O8 combined with water to give you 2 ammonium bisulfate plus H2O2. So this is the way how ammonium bisulfate can produce hydrogen peroxide. This was our fourth method. Then we come to fifth method. From 2-ethyl anthraquinone. This is 2-ethyl anthraquinone. It is treated with hydrogen. In the presence of nickel, it will give you first of all 2-ethyl anthraquinone. This is further heated with oxygen. It will produce H2O2 plus the same compound from which we started, 2-ethyl anthraquinone. So this is H2O2. So these are the 5 methods of generating H2O2. Then we have the important step, the H2O2 so produced by 5 methods. It is contaminated with water, it contains large quantity of water. Then how to separate water from H2O2 sample? This is done in following steps. Number 1, evaporation on water bath. The H2O2 sample so obtained, it is kept on water bath and is heated. When water evaporates, leaving behind H2O2. Then evaporation in vacuum desiccator. Vacuum desiccator is a double neck vessel. In the lower neck, we either keep H2SO4 concentrated or we keep anhydrous calcium carbonate, which so absorbs water from the H2O2 sample. And here percentage of H2O2 in the sample reaches to 90% and water is hardly left, 10% water is left in that sample. Now third step will be the distillation of this sample. When this sample is distilled, the H2O is distilled out, leaving behind H2O2, and now percentage of H2O2 in this sample in the third step, it reaches to 99%. And the last traces of the water, that is 1% or less than that, they are removed by keeping this sample in the atmosphere of carbon dioxide or ether, which absorb the remaining water from this sample, and the H2O2 so obtained from the fourth step, that is 100% pure H2O2. Now where to store it? H2O2 being less stable, it is easily decomposed into water and oxygen in the presence of dust particle or in the presence of metal oxide. Therefore, it should be handled or stored carefully, and it is kept in polythene bottles. It is not kept in glass bottle because glass catalyzes the decomposition of H2O2 into water and oxygen. Therefore, this sample is to be kept in the your polythene bottles, and sometime phosphoric acid, acetanilide, they are added to this sample to prevent the decomposition of the H2O2. Glycerol is also added sometime. So the H2O2 does not decompose because whatever the impurities or oxygen will come here to decompose H2O2 sample, they will be consumed by these substances. Then we have method of expressing concentration of H2O2. There are two methods. Number one is strength method, percentage method. In this method, concentration is expressed in the term that 100 ml of the given sample produces how much, contains how much of H2O2. So if we say 10% H2O2 sample, it means if we take 100 ml of this H2O2 sample, it will contain only 10 ml of the H2O2. So this is very simple percentage method. Then we have second, the volume method. We have already discussed it. We have the volume strength of the H2O2. Suppose I say 10 volume, 20 volume, 30 volume, 40 volume. What does it mean? It means that 1 liter of this sample, when decomposes, it will produce 10 liter of the O2 gas. In 20 volume, it will produce 20 liter of O2 gas. In 30 volume, it will produce 30 liter of the O2 gas. So in this manner, volume strength is expressed in terms of the volume of oxygen produced by the H2O2 sample on decomposition. If I say 10 volume of H2O2, it means 1 liter of the given sample that will produce only 10 liter of the oxygen on decomposition. Similarly, if I say 20 volume, it means 1 liter of the given sample on decomposition will produce the 20 liter of the O2 gas. So in this manner, we can calculate strength, normality and molarity of H2O2 samples. Let us calculate one case here. First is the percentage method. It is the volume of H2O2 in ml present per 100 ml of given H2O2 sample. Then second method, we have volume method. It deals with how much O2 in liters can be produced by 1 liter of given sample of H2O2. Suppose I say 10 volume, means it gives 10 ml of O2 from 1 ml of the given sample. Or 10 liter of O2 from 1 liter of given sample. To calculation purposes, what we do, calculation. We take the decomposition reaction of H2O2, it decomposes to give you H2O plus O2. 68 gram of this sample produces 22.4 liters of oxygen. 10 liter will be produced by how much? 22.4 liter of O2 given by 68 gram of H2O2. 1 liter will be given by 68 pound 22.4 liters, and 10 liter will be given by 10. So this will be solved. This will be the strength of this will be the amount of H2O2 in the given sample per liter. To know normality of such samples, we have y upon 17. To know molarity, we will do y upon 34. So if you want to know the normality divide the given weight with your equivalent weight. If you want to know molarity, divide the given weight by the molecular weight. You will get the normality and molarity. And strength is very simple. We have already explained that. Similarly, now you go for the calculation: 20 volume, 30 volume, 40 volume, 50 volume, 60 volume of H2O2. You practice it, you will be expert of the calculation. Then we have the physical properties of H2O2. Now what are physical properties of H2O2? Physical property: pure H2O2 is a thick liquid and it is having a bitter taste. It is moderately soluble in water and alcohol due to hydrogen bonding. Then decomposition: H2O2 decomposes to produce water and oxygen gas. Acidic nature: it combines with NaOH in two steps and releases two protons turn by turn. So chemical properties: first is decomposition. H2O2 decomposes itself to water and oxygen. Second is acidic character. H2O2 combines with NaOH, releases water and give NaHO2. It further combines with NaOH and will release one more hydrogen here and will form Na2O2. This shows the dibasic nature of the H2O2. Then it shows the oxidizing as well as reducing character. So action: oxidizing action. It reacts with potassium nitrite, converts it into KNO3 plus H2O. Sodium sulfite reacts with H2O2, giving you Na2SO4 plus water. KClO3 combines with H2O2, get converted to KClO4 plus H2O. PBS combines with 4H2O2. This is black color substance. It will become white PbSO4 plus 4H2O. ZNS similarly it is grey colored, combines with 4H2O2, giving you ZnSO4 plus 4H2O. So in these reactions we are converting the compounds H2SO3 reacts with H2O2, giving you H2SO4 plus water. H2CO3 also combines with H2O2, giving you 2H2O plus carbon dioxide plus O2 gas. So these are the oxidizing reactions on the compound H2O2. Now can attack on sodium thiosulfate, it can attack on ozone. This is the reaction where it appears to behave as both. H2O2 combines with O3 to give you H2O plus 2O2. So here both of them they are appearing to behave as oxidizing as well as reducing agent. Then we have the action in the alkaline medium. In neutral medium, these reactions are all in the neutral medium. No acidic or basic medium is required here. Cl2 also combines with H2O2 in the neutral medium. Cl2 plus H2O2, 2HCl plus oxygen. This reaction is used in the paper industry and textile industry for anti-coloration. Chlorine is used as a bleaching agent some of the chlorine remains in the fabric or paper, that is removed by this method. Then we come to few more properties. Action on the chromium, manganese sulfate and chromium sulfate. Oxidizing action on manganese sulfate. MnSO4 combines with H2O2. So we have the reaction MnSO4 plus H2O2 in the basic medium plus 2NaOH. You will get here Na2SO4 plus MnO2 plus 2H2O. So this oxidizing action is done in the alkaline medium. We have another reaction where chromium sulfate Cr2SO4 thrice combines with 3H2O2 plus 10NaOH. It will give you the products sodium chromate 2Na2CrO4 3Na2SO4. And along with that it will produce 8 water molecules. Then we have the reducing character of H2O2. In reducing character, it takes off nascent oxygen from other substances, changes to H2O plus O2. Action on chlorine is a reaction of this category. We'll get 2HCl plus O2 in this case. Action on metal oxides. Ag2O plus H2O2 will give you 2Ag plus O2 plus water. Similarly, Hg2O combines with the same, we get 2Hg plus O2 plus water. So metal oxides, they lose their oxygen when combined with this. H2S reacts with water, H2O2 to give you 2H2O plus sulfur. Then we have action of Ki in the presence of concentrated H2so4. We get K2SO4, we get iodine gas, 2H2O. So this is the action on your potassium iodide, K2SO4, 3 water plus iodine gas is obtained during this reaction. Then we have action on ferrous sulfate. Ferrous sulfate will change into ferric sulfate, 2FeSO4 plus concentrated sulfuric acid plus H2O2, you will get Fe2SO4 thrice plus your 2H2O. So ferrous sulfate oxidized to ferric sulfate. Then action on potassium ferrocyanide, 2K4 FeCN6 combines with H2SO4 plus H2O2, you will get 2K3 FeCN6 potassium ferricyanide plus K2SO4 plus 2 water. Reaction on chromium sulfate Cr2SO4 thrice plus H2O2. K2Cr2O7 combines with H2O2 and sulfuric acid. We get K2SO4, Cr2SO4 thrice, H2O. So K2Cr2O7 plus H2SO4 plus H2O2, you get K2SO4, we get CrO5 in this case. It is another product, a brown color compound, CrO5. Structure is like this. This is CrO5, this is a blue color compound. So this is the property. Then we have give some test for H2O2 sample. H2O2, it turns moist starch iodide paper into blue colored paper. It turns lead sulfide into lead sulfate being black, lead sulfate is white in nature. On treatment with acidified solution of titanium salt, orange color is produced, that is due to formation of H2TiO4, that is called as pertitanic acid. So these are the this is all about our chapter hydrogen. Tomorrow we'll take with the first chapter, that is S block elements. Thank you very much.